Imagine standing on a boat in the middle of the open ocean, calm water in every direction, nothing but blue as far as you can see. 3,000 feet beneath your hull, lava is pouring out of the seafloor at over 2,000 degrees Fahrenheit. Vents are erupting, rock is melting and reforming in real time. An entire mountain range is being built, piece by piece, in total darkness, and you would never know any of it was happening. No smoke, no tremor, no warning, just calm water, hiding one of the most violent processes on the planet. Most people assume a volcanic eruption looks the same everywhere: fire, ash, a mountain exploding into the sky. But scientists estimate there are over 1 million volcanoes hidden beneath the world's oceans, and the overwhelming majority of them will never break the surface, never form an island, and never be seen erupting by a single human being. So what's actually happening down there? And why does the ocean swallow eruptions that would be catastrophic on land? Let's go down and find out. To understand why most underwater volcanoes stay hidden, we first need to understand what's crushing them from above. At just a few thousand feet underwater, the pressure of the water is already roughly 100 times greater than the air pressure we feel at sea level. Some deep volcanic sites sit under pressure 250 times greater than what you're experiencing right now reading this. That's not a small detail. It fundamentally changes how an eruption behaves. On land, a volcanic eruption is explosive because magma is full of dissolved gases, carbon dioxide, sulfur, water vapor, trapped under pressure as the magma rises. As that magma nears the surface, the pressure holding those gases in solution drops rapidly, and the gases expand violently, like shaking a soda bottle and popping the cap. That expansion is what throws ash, rock, and fire miles into the sky. Underwater, that exact same magma rises toward a vent, but the pressure never drops the same way. The weight of thousands of feet of seawater keeps pressing down, keeping those dissolved gases locked inside the magma instead of letting them expand into a violent blast. Most underwater eruptions, then, aren't explosions at all. They're slow, glowing rivers of lava, oozing across the seafloor, methodically building upward, one quiet layer at a time. This is where most assumptions about volcanoes completely break down. People picture a volcano as a single dramatic event, but the vast majority of volcanic activity on this planet, an estimated 75% of it, happens exactly like this: deep, slow, and completely invisible from the surface. But pressure alone doesn't explain everything. To understand the rest, we need to look at what happens the instant that 2,000-degree lava actually touches the freezing water around it. The temperature difference is almost impossible to picture. Lava emerging from these vents can be hotter than 1,400 degrees Celsius. The seawater surrounding it, at these depths, often hovers just above freezing. When that lava makes contact with the ocean, the outer layer doesn't slowly cool like it would on land. It essentially flash freezes on contact, forming a solid, glassy crust around the still molten lava flowing inside it. As more lava pushes forward beneath that crust, it bulges outwards, cracks, and oozes out in rounded blob-like shapes that harden almost instantly into smooth lobed formations geologists call pillow lava. Layer after layer, these structures stack on top of each other, slowly forming long ridges and underwater mountains called seamounts that can take hundreds of thousands of years to reach any meaningful height. Most seamounts ever get anywhere close to the surface. They simply stop growing, stranded thousands of feet underwater, permanently invisible monuments to volcanic activity nobody will ever witness firsthand. But every so often, something different happens, and one of the best examples almost slipped past scientists entirely despite being one of the largest eruptions ever recorded. In 2012, a volcano called Havre, located in the southwest Pacific near Tonga, erupted continuously for up to 90 days. Lava poured from 14 separate vents simultaneously. Scientists later calculated the volume of material released: lava, pumice, and ash, was comparable to the entire 1980 eruption of Mount St. Helens, one of the most destructive volcanic events in modern American history. And almost nobody noticed. The eruption happened roughly 3,000 feet underwater, and the only initial evidence was a floating mat of volcanic pumice discovered weeks later drifting across hundreds of square miles of open ocean. An eruption with the destructive force of Mount St. Helens occurred, and the planet's only immediate clue was some floating rock. This raises an obvious question. If pressure suppresses explosions this effectively, how does any underwater volcano ever manage to break the surface and form an island at all? The answer comes down to one simple, brutal mechanic: time and elevation. Every time an underwater volcano erupts, it adds another thin layer of hardened lava to its summit. Over tens of thousands, sometimes millions of years, layer after layer accumulates, slowly raising the volcano's peak closer to the surface. As the summit climbs, the water pressure pressing down on it gradually decreases. Eventually, if the volcano survives long enough and erupts often enough, its peak crosses an invisible threshold, shallow enough that water pressure can no longer fully suppress the expansion of dissolved gases inside the rising magma. At that point, the eruption style changes entirely. The volcano stops oozing quietly and starts exploding, the same way it would on land. This is the exact mechanism behind the creation of volcanic islands like Hawaii, Iceland, and the islands of Samoa, all built from underwater volcanoes that patiently climb toward the surface over unimaginable spans of time. But what happens when a volcano erupting in genuinely shallow water finally breaks through? The 2022 eruption of Hunga Tonga gave the entire world a terrifying answer. Unlike Havre, which erupted in relative obscurity thousands of feet down, Hunga Tonga sat in shallow water near the island nation of Tonga. When it erupted in January 2022, the explosion was so violent it sent an ash plume 36 miles into the atmosphere, and the resulting sonic boom was reportedly heard as far away as Canada, thousands of miles from the eruption site. The underwater shockwave triggered massive landslides, dislodging over 2 square miles of seafloor sediment that thundered down into the surrounding ocean basin, disturbing marine ecosystems far beyond the eruption itself. Hunga Tonga is the exception that proves the rule. It erupted close enough to the surface that water pressure could no longer contain it, producing a blast that more closely resembled a land eruption than anything happening on the deep sea floor. Compare that to Havre, erupting with similar total force just a few thousand feet deeper, and the difference is staggering. One was barely noticed, the other was heard across an ocean. So the next time you're floating on calm, quiet water, somewhere out in the open ocean, remember what that calmness might actually be hiding. Beneath you, an entire hidden world of volcanoes could be erupting silently, building mountains nobody will ever see rise, layer by layer for thousands of years, completely unnoticed by everyone living on the surface above them. Most of this planet's volcanic activity isn't loud, dramatic, or visible at all. It's slow, patient, and almost entirely hidden. A reminder that some of the most powerful forces shaping our world are happening right now in complete silence, just beneath our feet. If stories like this make you think differently about what's happening beneath the ocean's surface, stick around. There's a lot more hidden down there we haven't covered yet. And let me know in the comments, does it unsettle you to know there could be an active volcano erupting right now, somewhere beneath a calm, ordinary-looking stretch of ocean?